lecture, I want to cover what are some of the important climate projections for the next century, and then what are some of the things we can do to adapt to a changing climate or to keep the climate from getting worse, called mitigations. So basically, I want to talk about where are we headed and what can we do about it. There are many difficulties in projecting what climate will look like over the next century. First off, we don't know what future CO2 levels will be. Do we use the past and just continue that trend? That would be the red line. Or do we assume the world will get together and limit the amount of CO2 we emit into the atmosphere? So in short, there are many different pathways CO2 emissions can take, and these are called representative concentration pathways, or RCP, which is written on your screen. So the figure shows the projected greenhouse gas concentrations for 4 different pathways. The top one, the red one, assumes that greenhouse gas emissions will continue to rise throughout the current century as they have been for the last century. This assumes that economic benefit will drive national and individual decisions and assumes burning of all fossil fuels. And that would raise CO2 levels to 1100 and above, and that'll peak just before 2200. And the bottom pathway is the most optimistic, which assumes that emissions will reach a peak between now and 2020 and declining thereafter. And so you can see there's the corresponding temperature increase that would be associated with each one of those RCPs. So it's all based on what we think we will do in the future. Projections of temperature change could be as low as 0.9 degrees Celsius or as high as 5.4 degrees Celsius. Also, population is an important variable because the more people on Earth, the more energy and things we use, all of which produce some sort of emissions. Since increase in CO2 can be viewed as the increase in population times the change in emission per person and changes in efficiency of carbon use. What our population will be has a huge influence on CO2 and therefore temperature. And once again, there are a number of scenarios that the United Nations has put forth to what our world population will look like by the end of the century. And on the screen, you can see there are 4 different pathways that fertility can take. The medium variant is a projection that United Nations researchers see as the most likely scenario. And then in that scenario, we would peak at about 12 billion people in the year 2100. So it basically depends on what fertility rates are in the future, and that would affect industrializing nations. So what are some of these projections based on the most realistic CO2 calculations and population numbers? So what are some of the temperature projections for the next century? So what's in store for the future? Most climate models project between a 3 and 5 degree C temperature change by the end of the century. And once again, this depends on fertility rates and CO2 levels. And we would also expect sea level to rise by about 1 to 4 feet by the year 2100. Once again, this depends on what the temperature of our oceans are and how much melting there is at the 2 ice sheets, Greenland and Antarctica. So however you look at, the outlook is not so great. We will see an increase in Earth's temperature. We will see changes in the amount and patterns of precipitation, reduced snow and ice on land, as well as sea ice cover, which changes albedo. We'll see rising sea levels, increases in acidity of the ocean, increase in the frequency and intensity of extreme events, hurricanes and other storms. We'll see shifting ecosystems, and all of this will become a threat to human health. So what are we going to do about it? Well, global change is a global commons problem, meaning effective mitigation will not be achieved if individual countries advance their own interest independently. It's got to be a collective effort of all nations in the world. In general, there are 2 very different strategies when it comes to dealing with climate change. We can try to stop or decrease future warming, which would be called mitigation of climate change. Or we can find ways to live in our warming world, and we would call that adapting to climate change. These two approaches vary in terms of the scope and the purpose. Mitigation, therefore, attends to the root causes of why climate is changing, while adaptation addresses the impacts that climate change is having. And most people concerned with climate change agree there needs to be an integrated portfolio of policies that include both ways to avoid greenhouse gas emissions, mitigation, and those aimed at coping with the impacts of global warming adaptation. The disagreement really is where the emphasis should be. And also at what cost and to whom. Those are the points of disagreement. So climate resilience is the ability to anticipate, prepare for, and respond to hazardous events related to climate. So improving climate resilience involves assessing how climate change will create new or alter current climate-related risks. And then what are the steps to take to better cope with these risks? And that's really what climate resilience is. And it's often associated with kind of acute events like flooding or hurricanes or wildfires. These will become more frequent as climate changes, but good resilience also accounts for chronic events like slowly rising sea levels, worsening air quality, or population migration. All of these happen much more slowly, but must also be addressed. So all that together is really what we would consider climate resilience. So how do we build resistance to different parts of climate change into our society? Well, there are a whole set of strategies, and I want to go through some of them. So some of the strategies for dealing with heat waves might be creating heat preparedness centers, identifying vulnerable populations of young, old, people that are disabled, and opening cooling centers during extreme heat. It might also involve cool and green roofs and cool pavements to reduce the heat island effect. Here's a picture of the roof of the California Academy of Science, which is a green roof that would cool that building. Planting trees to provide shade and evapotranspiration, which would cool the air around the trees. And then also pursue energy efficiency, which would reduce the demand on the electricity grid during heat waves. So these are all methods to help increase heat wave resilience. So what about flood resilience? We're going to see more hurricanes with more water as a result of climate change. So what can cities do to build flood resistance? Well, they can update zoning regulations so that buildings and infrastructures are built on higher ground and not in flood zones. They can update building codes and design guidelines to raise buildings. They can also limit the use of non-permeable surfaces like pavement and concrete and replace them with green infrastructure that can absorb water instead of increasing runoff. They can also separate stormwater systems from wastewater systems. This would reduce the likelihood of a sewer treatment plant being overwhelmed during a flooding event. And there are some areas that will see increased drought due to changing temperatures. So how do you build drought resilience? This is a tough one. You can water plants more efficiently and develop more drought-resistant crops. A new study shows that soybean plants can be designed to increase crop yields while requiring less water, which can also help offset greenhouse gas warming. This research about soybeans comes at a time when global food scarcity is threatened by population growth and climate change. United Nations estimates that food production will need to increase 70% by 2050 to meet the world's food needs. And soybeans is an important protein crop. So how can communities build in storm damage resilience? So how do you minimize the impact of hurricanes? Well, one way is by preserving coastal wetlands and dunes and reefs, which absorb storm surges so they don't hit the land with as much force or power. They can replenish beaches and improve infrastructure that affords coastal protection, such as seawalls. Once again, elevate vulnerable buildings to reduce flood damage. So those are some of the methods to reducing the damage that storms would create. Wildfires. Communities, builders, homeowners, and forest managers can reduce the likelihood and impacts of wildfires by updating zoning regulations, which would discourage residents from developing near fire-prone areas. You You can increase the space between structures and nearby trees and brush, clearing space between neighboring houses. Appropriate more resources for firefighting. These are all some of the ways to increase wildfire resistance. Keep in mind, all of these mitigation strategies are most easily accomplished by an industrialized nation, and a non-industrialized nation would have a lot of difficulty doing these. So mitigation would have to be part of the picture, especially for the industrializing nation. And mitigation is really looking at the root cause of why climate is warming and making changes to slow climate change by lowering the amount of greenhouse gases we put in our atmosphere. And this is really necessary to staving off a 2 degrees warming, which is an important threshold for our planet. And it fundamentally requires a change in how we get electricity. And we've got to shift from fossil fuels to renewable energy. And the way we do that depends. There are a lot of improvements in technologies. And we know where we're headed in terms of CO2, and we know where we want to be. And the difference between that is quite a gap. And how do we achieve that, closing that gap? This gap can't be reduced by a single method. Instead, several methods, often called wedges, will need to be combined to reach the target. So web technology could be increasing solar, increasing tidal, increasing wind, increasing fuel efficiency of cars. And what a country or a city or a state decides to do and which wedge they decide to employ and in what amounts will depend. So there are 2 ways to stop increasing the amount of greenhouse gases in the atmosphere. You can stop putting so many greenhouse gases into the atmosphere, but you can also invent ways to get greenhouse gases out of the atmosphere. And this is called geoengineering. And one way to remove CO2 from the atmosphere is by carbon capture and sequestration. This happens at the site of a fossil fuel electric plant, where CO2 that comes out of the smokestack of burning of coal or natural gas gets captured and then re-injected underground, and it's stored in a place where oil is collected. So you basically are re-injecting that CO2 back into the ground and storing it so it's not going to the atmosphere. This has been being done on a very limited basis in a couple different countries. There's some other far-out ideas, such as iron fertilization. This proposal basically says we could seed the oceans with iron to increase phytoplankton populations. And these phytoplankton use CO2 by the process of photosynthesis, so if there's more phytoplankton, they will absorb more CO2. Sounds more like science fiction, and this is unlikely to be implemented, especially since we don't fully know the consequences for marine life of adding all this iron to our ocean, but it's something to think about. Next, I'd like to talk about the Paris Climate Agreement. It's the most historic climate change treaty ever created. It's an international agreement, and it brings all the nations together into a common cause to undertake ambitious efforts to combat climate change. 195 countries that have signed on have agreed to reduce their greenhouse gas emissions to varying amounts and at different times, but it will collectively stave off a 2-degree temperature increase. And each country makes a pledge for their greenhouse gas emissions that will begin occurring in 2020. 195 countries have signed on, and they represent collectively 97% of all greenhouse gas emissions. It starts in 2020, and a large number of countries have signed on. But what's historic about it, in part, is that all of the developed nations have helped set up a $100 billion green fund to help developing nations reach their goals. So it basically sends a very clear message to the fossil fuel industry that much of the world's remaining oil, coal, and gas resources must stay in the ground and cannot be burned. So it calls on alternative technologies to reduce greenhouse gas emissions. The United States had signed onto the agreement under the Biden administration, but on January 20th, 2025, the first day of Donald Trump's second term, he announced his intent for the U.S. to withdraw from the agreement. This process does take 1 year to happen and therefore will take place in 2026. Although the United States as a country is not participating in the Paris Agreement, there is a more local movement afoot that is bucking that trend. It was started by Jerry Brown and Michael Bloomberg, and it's called the U.S. Climate Alliance. And 25 states have committed to the Paris Agreement, and they are committed to reducing their emissions 26% below 2005 levels by 2025. So there is a movement on a state-by-state basis. And collectively, these 25 states represent 55% of U.S. population, 50% of the gross domestic productivity of the U.S., and it's an economy that's larger than all the countries except the United States and China. So they represent a huge number of our population, of our economic interest, and of our states. And along with that, there are 407 mayors that have signed on to the requirements of the Paris Agreement. And they represent cities and 70 million Americans. They'll honor, adapt, and uphold the commitments to the Paris Agreement. One argument by Donald Trump and his administration for leaving the Paris Agreement is that it would create economic hardship on our country to reduce greenhouse gases to that level. And I would suggest they take a look at California. California has proven that an economy can grow as emissions decrease. So you can see our GDP in California has increased from 2000 to 2014. Our population has increased. And at the same time, our greenhouse gas emissions overall have decreased. Our greenhouse gas emissions per capita have decreased. And greenhouse gas emissions per dollar created has decreased. So that is proof that you can grow an economy and reduce greenhouse gas emissions. California is not only adapting to the Paris Agreement, they are going far beyond. Their goals are more ambitious. California has a goal of going 100% clean electric power by 2045. Currently, we have zero emissions, that is renewables and hydro, and nuclear energy is 32% of our electricity generation. So California is a leader in the fight to transition away from fossil fuels. There are some cities across the U.S. that have attained 100% renewable energy or energy supplies, including Aspen, Colorado, Burlington, Vermont, Georgetown, Texas. And then earlier this year, for 1 month, Portugal produced enough renewable energy to meet its entire electricity demand. But today's global energy infrastructure is mostly fossil fuels, plus a little hydro, a little nuclear energy, and very little renewable. So what's a country to do overall? What mitigation efforts? Well, use less energy, either by driving less, driving smaller cars, maybe plug-ins, conserve electricity, recycle, reuse. Number 2, make low-carbon energy, solar power, wind power, nuclear energy, tidal power. Or number 3, which is much more difficult, take CO2 out of the atmosphere. That's unproven and costly, but that's what we are striving to do. So where do we stand in 2019? Well, the Earth is getting warmer. Extreme weather events are happening. Most warming is due to people. CO2 is high and increasing. We'll have a dangerous Earth if it warms more than 2 degrees centigrade. We have ocean acidification, which is a problem. But fixes are large, but they're feasible. But fixes really need to be within the next few decades to avoid big problems. And that's what our world in California is confronted with right now.